Field sampling and testing. Learning objectives. Identify reasons for conducting field sampling and lab testing. Describe typical field sampling and testing procedures. Describe laboratory test methods and their applications. Describe the use of field and laboratory test result and rehabilitation design. Reasons for conducting field sampling and lab testing. So here's the reason for conducting the field sampling and lab testing. First is to complement and verify NDT. Next is absence of NDT, diagnose causes mechanism of distress, identify structural characteristic and layer material properties in existing pavement, economics, recycling, emphasis on rehabilitation. Typical field sampling and testing procedure, material specimen sampling, coring, auger, split spoon, shell by tube, test pit. Field testing, dynamic cone penetrometer DCP and ground penetrating radar JPR. Coring. It is widely used method for first laboratory test sample, next layer thickness determination or verification. Third is visually characterizing layer material types and condition. Coring is relatively inexpensive. Coring plans used to assess variability along a project. So here are the picture of removing a core, the thickness verification using coring, the distress cause identification. So here are the sampling approach of coring. Sampling location and frequency of coring. Standard location, outside lane, other wheel part. Frequency, number of samples depends on variability, uncertainty, project size, anticipated rehab cost, traffic and safety issues. Typical spacing 100 to 800 meter. Dynamic cone penetrometer, DCP. Device for measuring in situ strength of paving material and subgrade soil, correlated to California bearing ratio or the CBR. So here are the typical drawing or sketch of a DCB device. So it has a cone angle of 60 degrees. So it's a handle, a hammer, and steel rod, and the cone. So here is the DCP testing process, the picture. So here are the example result of the DCP. Ground penetrating radar. Laboratory test method and their application. Test methods and their application are dependent upon type of material, basic property being measured, material state of stress, typical properties measured in lab. So here are the typical properties that is measured in lab. Resilient modulus, surrogated for Young's modulus, fundamental engineering property, loading transition, triaxial, axial, indirect tension. Resilient modulus test. Triaxial used primarily for testing of unbound materials. So you can see the picture. So here the method for determination of the resilient modulus. Axial compression used primarily for testing of bound material. Heavier duty test equipment is used to measure compressive strength. So you can see the picture. Complex modulus, aka dynamic modulus, applicable to bituminous materials, equipment and test procedure almost identical to resilient modulus under axial compression. Primary differences in load pulse. AASHTO 2002 Guide for Design of New and Rehabilitation Pavement Structure. VIM Resistance Test or R value. So it is a stiffness measures for unbound material. Standard axial stress is applied. R value is basically the ratio of the applied vertical pressure to the developed lateral pressure. California bearing ratio or the CBR test. So you can see the saturated specimen. So it has a 50 mm diameter piston. Height is 180 mm and the width is 150 mm. So it is strength measure for unbound material. Piston advance at rate 1.3 mm per minute rate. Measure load at 2.5 mm penetration. CBR is equals to 100 times P 2.5 over P STD. Indirect tension test, aka splitting tension or split tensile stress test, used to determine the tensile strength and or MR of any bound material. 100 or 150 mm diameter specimen. Sample length should be at least half the diameter. Prepared sample or course. Evaluating pavement layers. Soil classification or the unified or AASHTO. Moisture content and density. DCP. Resilient modulus measured in the lab. Back calculated from NDT data. Estimated from correlation with the R value, CBR, and other soil properties. Unbound base and sub-base layers. Visual inspection, layer thickness, decoration, or contamination by fines, DCP. Density and moisture content, resilient modulus. Other consideration: volume stability, stripping, seasonal variation in moisture permeability. Use of field and lab in rehabilitation design. So you can read the use of the field and lab test in rehabilitation design, so it's stated here. So here is the key reference for this PowerPoint or this video, and that's the end of the video. I hope you guys learned something, and don't forget to click the subscribe button and the bell button right beside it so that you'll get notified whenever I upload a new one. Thank you.